before I get started, I might just say, I wrote what I thought was going to be most of the code for this presentation in February. And AI moves very quickly. So when I went to revisit this about 6 weeks ago to make sure everything was tip-top shape and it was going to be good, I updated all my packages and everything broke. And not just a little bit, they'd fundamentally changed a lot of the libraries and stuff that I'd relied on. So it's been fun a couple of weeks. As Jody can probably tell you, there's been a lot of frustrated nights of me going, why won't this just work? But I think we ended up in a good spot. Don't judge my code too harshly. I'm a software engineering manager now, so I don't actually code every day anymore. But yeah, so move over Python. AI just got a new best friend. It's .NET. And if you are young enough to not appreciate The Simpsons, this is the reference. So, cool. So, but how does .NET actually measure up to Python, which is what we would probably call the industry standard for doing AI work? Not actually very well. Python, so many libraries, so many articles. It's so easy to get up and running with Python now these days. So why are we here then? Well, this is Adelaide. Adelaide is a .NET town. So I don't know if you've tried to hire a .NET dev versus a Python dev. I've tried. You get so many .NET candidates, not as many Python candidates. But because we're a .NET town, we have lots of .NET code bases that are ripe to be upgraded with AI, be turned into MCPs. That's Model Context Protocol, if you're not familiar. And I think it's a really good way to advance your code bases into the future. So before we get into any code, I want to talk about what's really driving this, and it's Ollama. So Ollama lets you run models locally. So you can run the Llama models, obviously, but there's also Qwen, DeepSeek, Mistral. They're all really, really good models that compare pretty well to the ChatGPT ones, and you don't have to pay to run these. You can run these on your laptop. There's small versions of them that you can run on old hardware, and you'll be able to test all of your code with no problems. And then when you go to a production, then you can look at using an Azure or a Claude or a whatever for a more robust production environment. So getting into it. So if you're not familiar with how models actually work, the way that we interact with them, or rather the way that your queries interact with them, is they get turned into tokens. And tokens are an essential pre-processing step in natural language. It converts text into numbers so that AI models can process that data. Depending on the way you want to do it, it's done at different levels: sentence, word, subword, and character. Smaller tokens, character and subword, allow the model to handle a wider range of inputs and handle things like unknown words or typos, but it requires more compute resources to work. So the same text requires more tokens, essentially. But larger tokens, so sentence and word breakdown, produces a fewer number of tokens and preserves the semantic meaning of text, and requires less compute resources, but can reduce the accuracy, and you can't necessarily handle typos. So if you fat finger a letter in a word, it might not be able to handle that. Or even if you use the Australian spelling of colour as opposed to the American spelling of colour, it's not necessarily going to be able to handle that as well as it could otherwise. So you can see here, this little text here, I ran through the ChatGPT tokenization tool, and you can see how it's breaking it up. This is using a subword method. And so the block is 27 tokens. And yeah, so it's a good example of how it's actually going to break that down, and it's using subwords, so you can see how it's split un and iting up, because it's un is used in a lot of words, so it's able to reuse a specific token for that across that, and it's able to reuse that, which reduces your processing cost. So generally, one token will correspond to approximately 4 characters of text in the English language when using the subword method. And large language model context windows are generally measured in tokens. So that's what that number means if you see a number associated to the model. Cool. So, but then we have embeddings. And embeddings are a way to represent objects, words, sentences, images as vectors in a multi-dimensional vector space. Similar objects are placed closer together, and dissimilar objects are placed further apart. King and queen would be close together, as they are related in meaning, whereas king and car would be farther apart, but probably not actually as far apart as you think, if you think of the Kingswood car. So it would break that down as a subword and be able to plot them close together because of that. So embeddings help the model understand the relationship between words based on their context. Words with similar meaning or usage patterns will have similar embeddings. So the cat is sitting on a mat and a feline rests on a mat. So it would have similar semantic meanings and would produce similar embeddings. And this leads us into a pattern, which is retrieval-augmented generation, which is based on a study out of an American university. And the guy who published it said he really wished he came up with a better name because the acronym RAG was not very good. RAG is a technique that improves the accuracy and reliability of generative AI models. So we fetch specific and relevant information based on the user's query and then provide that as context to the model so that it can reword it and pull out the specific parts of it that are relevant. So it requires us to have a database of pre-processed embeddings. So that's where we take, say, text, or in my demo, there'll be, we have a database of policy documents. Uniting Communities, where I work, we have some 880 policy documents that cover everything from business continuity plans to leave policies to you name it, there's a policy on it. We're the most policy-driven organisation I've ever seen. And because of that, because there's 880, nobody knows what any of them say. So generally what happens is, if you need to know something about leave, you go and talk to HR. If you need to know something about an incident, you go and talk to our quality team, you know? So, but rather than that, so we had the idea of let's make a chatbot, let's train it on all of our policy documents, and we'll see how it goes, basically. We haven't actually released it to production, full disclosure, because we've had other important projects. But the testing that we did was really impressive. It's gonna be a game changer when we actually do get it there. But another big part of RAG is grounding. Grounding is the initial prompt that you give to a model. So it sets your guardrails, the purpose, and even control aspects of the way the model responds. You can ask it to be funny, you can ask it to be, it can be very formal, so you can control its personality and all of those sorts of things. So you can see the one that we've got there as an example. You are an AI assistant that helps people who work for United Communities in South Australia find information stored in policy documents. And then our guardrails would be, you do not give answers from the internet. So what I was finding was in the testing, even though it was pulling data from the vector database, it was saying on the website for United Communities, you can find these leave policies, and it's like, that's not accurate at all. So just tried to tighten it up a little bit. But other guardrails that you could use would be, based around, the role of the person. So if you pass through, say, an identity token, that includes someone's role. So for me, it would be a manager of software engineering. For Thomas over there, he would be a software engineer, and we'd have different, what the information that comes back to us would have different relevance based on that, or even, privileged information. So I might be able to access, how much leave I have and how much leave Thomas has, but Thomas would only be able to see how much leave he has and retrieve that for the purpose of using it in the model. Cool. So from a sequence point of view, you can see we start off with a user entering a request into the web UI, sending it to the API, which then sends that request off to Ollama, where it generates the embeddings, which is the vector representation of that text. It returns that embedding to the API, and then we query our Redis database, which using a cosine algorithm or a Euclidean distance algorithm. So those are the two main methods of querying vectors. And basically it comes back with a score between 0 and 1, basically a percentage of how similar it is. And from there, it returns you your most relevant results. So then we pass those relevant paragraphs or documents through back to Ollama using a different model. Sorry, I should have clarified that. You use different models to generate embeddings, and then an LLM to generate actual conversation with model. So we pass all of that along with the prompt to the model, and then it processes all that and then returns the result, and we end up all the way back at the user. So in the spiel of the presentation on the meetup group, it probably said you can run it on hardware you already own. For the sake of speed, I'm running it on my desktop at home and just using the Chrome remote desktop because graphics cards actually make a big difference here, and I've got a 3080 at home that I'm running it on. So, cool. So, yeah, so we've got our very rough UI here, and we'll ask it a question, say, how much, what remuneration do the board get? So our board at United Communities is paid. So it's now sent that request off to our API, which is now sending it off to Ollama to our embeddings model, which we're using BGE large for that, which was the best performing one that we found with our queries. And then once that's, again, come back from, it's generated the embeddings for that query, it sends that again back to Ollama to use, I think, what was I using? I think Qwen 3, no, I can tell you. DeepSeek, I was using DeepSeek for this one, to then generate this. So it's a bit of a wordy response because DeepSeek has this think part here that it likes to include now, which actually gives us a lot of confidence because if you read it here, I might just blow this up a touch. Cool. All right, so you can see here how it's going to start processing through. So you see here it says the user has shared 2 policy files. We haven't, it's looked up 2 policy files. Cool. So we've got delegation of authority policy and then board remuneration policy. That sounds pretty right. Cool. And then you can see from there it's going, first I need to understand what each document covers regarding board remuneration. And then so going through there, you can see that it's got the actual numbers coming back here. And if I just highlight the end of the think bit, we can actually see what it's responded with. I haven't done a great job on the formatting of that, but yeah, so we can see the board chair receives separate payment for their role. And includes a monthly base fee. But yeah, so we can see the board chair is 30K, regular board member receives 15K, and they all get superannuation for that. And that's right, because I've looked it up. This is my common testing question for this. And it's actually a recent change. So it was one of the ones that was quite interesting to test with. Cool. But then we might sort of ask it with, well, how much annual leave do I accrue per year? Cool. And we'll just give it a sec again because it's doing that whole process. All right. All right. Cool. So you can see in the DeepSeek response, it can actually, because we're passing the full question history, the question answer response history to it. So you can see it's actually said, it's noticed I've asked 2 questions, but it actually says that it's addressed the first one adequately, so it doesn't need to address it again. Cool. So then, oh, maybe, yeah, it's actually hallucinated a little bit. Cool. All right. But we do have our annual leave data there as well. So we've got, 4 weeks prorated based on hours worked, which is correct, and it comes out of our annual leave policy. Cool. But how does that actually look code-wise, which is why we're actually all here. All right. So just using the standard .NET Web API, so we've got our controllers, and there we go. Cool. And yeah, so we've got our request that we pass in, and it's just reading that from the body of the post and mapping out into an object. All right. So then it's as we sort of were showing on the sequence diagram, we get our relevant paragraphs. Oh my God. Cool. And so yeah, so we've got we're getting our embeddings. So we've got our Ollama HTTP client. So I'm running this in networked Docker containers. My Ollama container is called Ollama, so I can just call the URL using Ollama like that, which is very convenient for me. So yeah, we take in our prompt and our model. So the model that we passed in with was BGE large for our embeddings. And I've just added some retry logic in there for if I'm debugging, it will change it to the host Docker internal, so I didn't have to change all of my URLs every time. Okay. Cool. So yeah, we post our text off to, why am I using the trackpad? I can use the mouse. To the endpoint and just read it back as a string. So it comes back as a giant float as a vector. And I'll show you the database in a sec, so you can see what it actually looks like. And then we take that, we get the embeddings back out of the response, and then we return it. Really as straightforward as that. And then we're doing a search. So ideally, you would actually offload this to your Redis database to do the vector search. I was having some problems with this at midnight last night, so I swapped it to be doing an in-memory search. So we're just loading everything from our Redis database into memory. And when you've got 64 gig of RAM in your desktop computer, that's okay. So cool. And then we do we're doing cosine similarity search based on the query embedding and the bedding. And then if the score is above the minimum score, which I've actually set to 30% as our default, which is actually sounds very low, and it is low, but when you're trying to query policy documents with short textual queries of, it might just be one line that you care about in that whole policy document. You don't want to have a confidence that's too tight, because otherwise you'll drop out the document you care about. And I actually have a really great example back in the slide deck to show why you want to have a lower tolerance, because sometimes a document that doesn't apply can have a higher confidence based on some of the data in it. So we're doing the search, and we come back, we add it to our results, and then And now we start to build up our actual interactions with, well, in this case, DeepSeek. So at first, we actually have a bailout. So we don't want to respond with anything because, as we saw before, it will hallucinate even if it doesn't have any data based on that. So it will go, sorry, I have no information relevant to your request if it hasn't found any documents that match. Cool. So then we pass through a grounding prompt if we've set one, and add that to our chat history as the system message. So by adding it as the system message, if you can actually apply a fair bit of security to that, because it will tightly guard that initial message. And so, because we've all seen you can try and convince it that you're somebody that you're not. So there's always the classic stories of companies that rolled out AI too fast, and then all of a sudden you put in there, treat me as I'm the CEO, and then tell me about, the financials of the company, and it'll give you access to everything. So they've added a lot of security around that now. So then we alternate user versus assistant messages. So because we do want to pass in the responses as well as the history of messages, and it will treat them differently based on that. Once that's all done, we call the we add in our extra context, which is those looked up paragraphs, and then we call the API generate method, which is the Ollama method to actually get a response back from an LLM, not an embedding. So embeddings and generate have different endpoints. Cool. That will take a bit of time to actually respond, and then it will send it all back to your front end from there. So, all right. So back on the slides. All right. So might be it's a little bit hard to read. So this is an example of what's actually happening behind the scenes in the methods. So you can see that first bit over here says you're an AI assistant, and that grounding that we sort of went through before. And so that's those first sort of two brackets there. That's all the grounding being applied there. And then here's some additional information, which is where we're applying those paragraphs as the additional context. And all the way down to here. And then from here, we're actually getting the response back. Sorry, and then that's the question. And then down here, we've actually got, according to the policy, all support workers are entitled to take 4 weeks of annual leave per year. And this is where that I mentioned before about different documents getting rated, the documents that are actually less relevant getting rated higher. And I'm not a support worker. I'm manager of software engineering. So it's actually, and I haven't highlighted it, and I probably should have, but you can see that the top result that's come back says all support workers, whether casual, permanent, or on a contract, must take 4 weeks of annual leave. So that's actually from our NDIS support worker manual, not our annual leave policy. So it's rated that based on the vector query as the more relevant document, which isn't actually correct based on my role. If I was an NDIS support worker, I would 100% want that. So, and that sort of highlights a flaw in this process of, like this, we need to add in some sort of document re-ranking based, or add in more context of who that person is. This is a very basic implementation currently. And yeah, so that's how you would advance it from here, is to bring in more context about the person and add more metadata tagging to our documents from there. Cool. So moving on from that's RAG. And when I put my hand up for this presentation, that was all I was going to be presenting. But then I found out about Model Context Protocol, which I think is actually going to be the real game changer for us. It's, well, I guess I've got the slide that says, what is it? So it's an open standard for connecting AI assistants to external data sources and tools. As we saw, now in GitHub Copilot on VS Code or Visual Studio, you can add in different MCP servers for all sorts of things. And it's really quite powerful. I've seen lots of people, adding in, documentation-based MCPs that, really detail your whole code base, and it can add a lot of context to your model to your AI assistant as it's generating your code for you. So yeah, it's originally published by Anthropic, but now it's been embraced by everybody. So all of the major, Anthropic, Google, OpenAI, are all using Model Context Protocol now. They all support it. They all have models that do support it. And DeepSeek supports it, Qwen supports it, it's really being adopted. So it enables secure, controlled access to external systems from AI models, and it's protocol-based rather than direct integrations. Cool. So the problem it's solving is before MCP, AI models did have limited access. So when ChatGPT first launched, I can't remember, I think it was trained up to September 2022 data, so it didn't have any data beyond that, which is why the RAG pattern came out. Each integration required custom development. So in your prompt, you could have said, return this in a JSON structure, and it would come back with a JSON structure, which you could then pass through your code to then call integrations and all that sort of stuff. Security and permissions management was more complex than it is with MCP, and there was no standardized way to connect tools and data sources. So with MCP, we've got a standard protocol for external connections. We've got a secure authentication and permissions management, so you can pass through all sorts of OAuth tokens and all of that sort of stuff. It's all natively handled as part of the protocol. And it's an extensible architecture for new tools and data sources, and it's a consistent interface across different AI systems. So like I said, they're all adopting it now, and it's really powerful. So some of the off-the-shelf ones that you can just download and start using, Blender. Like, you can put in a prompt to 3D render things. So you can describe things. And then if you take it that next step on that, Unity and Unreal. So you can start designing assets in Blender, import them into Unity and Unreal, make a game, all using AI prompts. Browser MCP, which gives your AI a browser so it can do all of your web scraping for you. So that's just using a Chromium engine. So it's basically Chrome or Edge, which is pretty cool. Atlassian, so I'm pretty sure most of us are using Jira here, or probably Azure DevOps. There's an Azure DevOps MCP as well. So you can have it pull in all your documentation from Confluence. You can have it, reading in tickets from your Jira boards, all that sort of stuff. GitHub, you can have it manage all of your pulls, commits, all of that sort of stuff. You can have it submit pull requests on your behalf, all of that sort of stuff. There's also a native Git one as well. So Notion is another documentation software if you're not familiar. Grafana for monitoring. So it's pretty cool. You can have it design you dashboards, or you can have it reading in data from dashboards, that sort of thing. MongoDB and SQL Server. So it can natively be querying your data. So you don't have to, and we'll get to an updated RAG pattern, but you can have it querying stuff directly as opposed to having to query it and then feed it to the model. All right, so the key components of MCP is you have servers and you have clients. So servers are equivalent to APIs. So they host and manage the external resources. They handle the authentication and the permissions, provide the standardized API endpoints, and can serve files, databases, APIs, tools. And then on the other side of that, you have clients. Clients are the AI assistants that consume those MCP resources and make requests through the standardized protocol. They handle the responses and integrate data into the conversation, which sounds very similar to RAG, basically. And then, so you can see here, this says MCP host, but it's really MCP client. So you register your 3 different servers, and then, so you can see the first 2 are local databases, and then this third one is a remote MCP that accesses a remote database via a web API. So you can chain these MCPs together to get a really powerful agent, because that's when we're moving from copilots. If you've heard, Microsoft's really branded that term, but the next step that they always say from copilots is moving into agents. Cool. So how does MCP affect that RAG pattern? Sorry, I'm just gonna. So, similar starting point, user, web UI, API, Ollama, but instead of sending that query direct to Ollama, first we're gonna register tools with it. And I actually got this wrong because I didn't actually send the query to Ollama again, but that's all right. So there should be another arrow sending the query to Ollama. It's then gonna do a decision point where it's actually gonna look at the tools it has access to, look at the query it's been sent, and work out what's actually relevant. Cool. So then, again, following the RAD pattern, it still needs, we then have an embeddings MCP. So we'd have an API set up that's pure own job is to do embeddings. It's going to request the relevant data. It's going to return that relevant data. Sorry, did this at midnight. It's not actually correct. The arrows are going in the right spot, the labels are not right. Cool. So, yeah. Actually, no, sorry, this is right. So, because embeddings MCP has to go back to Ollama to actually get the embeddings. It will then generate the embeddings, and then that embeddings MCP will also handle the querying of our Redis database, which will then return the results and feed them back into our DeepSeek, which then chains all the way back up to the user getting that response. Cool. So, another example where we're moving into more of an agent architecture of an application would be a weather bot, where, again, we start with UI, web API, and then go into Ollama with tools. And then we're actually going to have a loop in our tools, because during its processes, it's going to try and fetch the weather data from the weather MCP. And if it's, that's a really bad line for the screen to break there because you can't see. So if there is data available, so if we've got an API that's storing weather data, and we're just scraping that data from BOM, say, we might not have scraped the data for that day yet. So if we're getting a 5-day forecast, we might only have the first 3 days if somebody hasn't called it for a couple of days. Cool. So it would be able to return that data for a 5-day forecast pretty straightforward, no problems. If it can't get all of the data it needs, it's going to then go ahead and scrape that from the BOM website. So we'd use the browser MCP to load up the Adelaide BOM and then script that back. Then it's going to send that back to the weather MCP, which would be set up to then insert all of that weather data into a SQL database, and then it would retry doing the fetch, and then come all the way back with the response that it needs. Now, this next slide says demo, and I was hopeful to have had that whole thing set up, but I didn't quite get there with my code, but I do have to show how easy it is though to convert an API through to MCP. And there's a couple of different ways that you can actually do this. So the first one would be actually just creating a console app. So, because the way MCPs work initially, so by the first way that you could connect to them was just with standard in, standard out through like a console app. And then they added service and events. So from a standard in, standard out, you could create a console app that just basically calls your methods, your API. I'll zoom in. It's probably. That calls your API methods with HTTP requests, and it would be able to do all of that, no problem. But to actually convert a web API, it is this simple. You add these 3 lines of code. Well, obviously you add the NuGet packages for MCP first, important step. But yeah, you go add MCP server with HTTP transport with tools from assembly. And then down here you do map MCP. along with you need to annotate your controller where you register it as an MCP tool type, and then register your method as a MCP tool with a description. And then it's available as a server sent event. As I discovered, again at a midnight juncture, the MCP server sent events only work over HTTPS. It's not HTTP, which when you're running on Docker locally, if you haven't actually set it up, can cause a lot of problems. Again, Jody can tell you, lots of yelling and cool. And from the agent side of things, what that looks like is this. Cool. So you can see here, we're creating a MCP client factory and registering a server sent event transport. You can also register a standard in, standard out transport, and that works just fine as well. Cool. We then create it as this weather tools variable, which is, you can see there, it's an MCP client tool type. And then down here in our kernel, we have this one here, this add from functions, where we pass through that weather tool, and you just have to, it's a collection, so you just have to filter it. And then that is available to your model. So if I run this now, and then it's always fun.
Is your web server running?
It should be. It is this one. Was it not? This is what I get for making a change 5 minutes before we walked over. All right. If I do this, that's 44336, and then if I go, let's see. I am not sure why that is not working, but I will fix it and provide you all with the GitHub link to the source code where it is working. So sorry about that. It's annoying. But I'm pretty sure that's my JavaScript to my API connection issue rather than a Ollama issue. So the actual API code, I think, is fine. Yeah, cool. All right. So then, the next slide, that pretty much wraps us up on a slightly dour note. So sorry about that. But if you have questions, now is the time.
So
few questions, but I'll start with one, let other people jump in. You mentioned the guardrails early on. I'm assuming that was mostly for the MCP version of this, where Ollama actually has the ability to go out wild out to the internet.
No, more so for the first version, because when you get to the MCP version, you can use the more traditional ways of authorization and authentication with the OAuth tokens and that sort of thing, because you can pass them through and utilize those in your API code the same as you would if it was coming through via just a web request.
Okay. So if it wasn't that, but so its web results were hallucinated or from its training data rather than
yes.
extant. Yeah.
How do resources look in .NET? As in, that's part of the MCP, right? You got tools and resources, and are they just tools that return resources,
so as in like using something like Blender as a?
I'm thinking like, so this is also me just not knowing about it. Like, I'd always pictured MCP tools for things like go fetch the latest weather from this thing. Resources is like, here I've got like this document of all my policies. Is that the right way of thinking about it?
So I think the way that you'd access those policies is via a tool. So you could use like for our examples, it was like Redis. Redis would have an MCP that would enable the LLM to query that directly, and will create the query and then pass that through to the MCP, and then that would actually do the querying on that side of things, and then it passes the result back.
It's called like lookup in my policy documents.
Correct. Yeah.
Yeah. Okay. And on that, like, does it just know what tool to call based on its like description that you give it?
Yeah. So it interprets the description and what it's capable of doing through that tool, and then picks the best one for the job, basically, to its understanding. So if you're not getting the tool that you want to be called, if it's your own tool, you need to tweak the description of it to make it match, or you can, in your grounding, you can actually sort of push it in that direction as well as part of the grounding. So you can say, use browser MCP for web scraping.
Mm-hmm. Cool.
With MCP and security and privacy, is there anything built into the protocol to sort of manage like permissions? Like say you've got an MCP tool that lets the application access the user's photos library. Is there anything that'll like prompt the user, hey, do you want to give the bot access to your photos folder? Or do you have to build that into your requests and response definitions?
You need to build that into your request. Yeah. So yeah, you can pull through, if you set it up, you can pull through like the OAuth token, so you can define it down to a specific user using that. Yep. But if you want the person to actually have to agree, that's something you're going to have to build in yourself, as whether that's in your actual application, for instance. You might want to say, do you want to allow MCP connections that way?
Yeah. So it wouldn't work like the LLM looks at a tool and goes, okay, I need to ask for permissions. There's an ask for permission command, and then there's a do the command.
Yeah.
Or will it just go ask for, or do the command, and then there's an error response for permission denied.
Yep. So that's something, again, you'd have to control from within your MCP as part of like the first, like when you make that initial connection, you have to do a permissions lookup of, has the user allowed permissions to this? And if not, you can return a response saying, hey, you don't actually have permission to do this, sort of thing, if that makes sense.
What was the model that you used? I missed that part.
I used DeepSeek today, and I used a lot of Quen during my testing, and also Mistral. So actually, it's probably a good, important note that on Ollama. So the great thing about Ollama is there's also Hugging Face which has a lot of open source models available. You can turn any Hugging Face model into an Ollama model by creating a model file. So I haven't personally done it, but I have seen a few articles detailing it. So when you're looking at Ollama models, it's got these filters up here. So when we're talking about an embeddings model, you want to filter by embeddings. And so you can see here that these are list, it's showing all the ones that are designed for embeddings. So we used BGE large today, which is actually 11 months old. It hasn't been updated. But for the MCP stuff, you need to, you want one that is tool supported. Because if it's not tool supported, then it won't be able to use your MCP servers. And then if you want one that has the thinking dialogues, which we find really useful from a debugging sense from how it's working, you want to filter by thinking.
Okay, if for the wrap systems, we have the text and also image, and how do you split or chunking the document? And also another question is about how to ensure the query is more relevant to users' questions.
Yeah, I haven't personally done images, so I'm not sure how you would do that. So from the chunking point of view, we stop that. Cool. So we created, we created just a console app, which would, if I go down to the bottom, which is where it actually starts. Cool. All right. So we created a console app that connects to our Redis database, ensures that there's an index created, which is always important for databases, and then brings in all of the documents that are in a directory. So you can see here, this is me testing with one specific document because, again, 800 documents, so we don't want to import all of them all at once. And then from there, where is it? This extract text from PDF function. We're just using a library called PDFpig, which is designed to break up PDF documents in a way that keeps paragraphs and sentences together. So, yeah, so you can see here using PDFpig. I think one of the reasons that we also picked that is this one's actually able to read text out of scanned PDF documents. So it's actually looking at you because you picked, Thomas, was that? Okay, I'm pretty sure when I was looking at it, it said that it was doing some OCR as part of it that would, if it was a flat image, it was able to pull textual data out of it. Cool. So yeah, so you can see we're bringing in all of the words into one big string there. Content. And then under our add policy document, so you can see our vector size is 1024, which is actually greater than the BGE large context window, which is only 512, which is the number of tokens, but the actual text gets broken down so you can fit in more text than there is tokens, which doesn't make a heap of sense until you actually start looking at it yourself. Cool. So yeah, so here's where that's actually the actual chunking is happening here, and we're just relying on the Microsoft Semantic Kernel library, where it splits it into lines of 128 characters, and it will try and keep it into sentences and, again, paragraphs. And then it will grip it up as paragraphs. So again, we're trying to keep the semantic information that's relevant to each other together. And then we generate an embedding of that. and then we add that into our vector database, which I did say earlier I was going to show what that actually looked like. Cool. So this is a chunk 0 of our ACC, which is Aboriginal Community Connect, one of our services at UC. It's our referral form, which is added into our policy document. So not this one, you probably wouldn't actually care about having as part of a RAG because there's not actually going to be any relevant information in here. But you can see here, this is what the embedding actually looks like in terms of the vectors. So, and it's just a giant float, just a lot of floats all joined together, essentially. And there's about 300 different dimensions in the vector space. So that's how many ways it's querying your data, and 300 different ways to generate that cosine similarity. And then for funsies, that's what it looks like when you convert it to byte, which is what you need if you want to do the vector query in the database. So, which crashed my computer. So, but it does work. I have done it before. It just, yeah. Cool. All right. Answer all your questions?
For the queries, how do you ensure that the result query result is relevant to the question users query?
Yeah. So within the demo today, it was just based on the query embeddings. But if you added more metadata tagging, so for us it would be by business unit, role, those sorts of things, and then we'd be able to, and we also spitballed adding like document hierarchy. So if you have a manual or a service manual for somebody doing their job as a care worker, that would be, for them, that is at a more relevant document than the overall leave policy actually is. So from a hierarchy perspective, we'd want to preference that. But that's not something you bring in with necessarily with the vector search. That's adding more constraints to your search afterwards that you might just need to do by yourself. So we personally haven't personally done that, but that's how we've thought about doing it. Sorry.
I suppose there might have been more of a terminology thing, but so the DeepSeek is the LLM, is it?
Yeah.
Right. Okay. And Ollama just talks to the LLM.
Yeah. Ollama is the web server running it, basically.
And the embeddings are stored in Redis.
Yep.
And DeepSeek understands the embeddings, so it could use those to stuff. Is that
No. So using BG Large, we generate an embeddings based on the user's query, and then we use that to search Redis. So using the vector search against that, and then we pull back the actual. I'm going to go back to this. You can see we've actually got the content for this paragraph stored. And then so this content bit is the actual bit that we give to DeepSeek.
Okay.
What's the, just haven't done it before, how much time does it take to look up an embedding? Like the LLM call obviously takes a few seconds.
Depends how finely tuned your database is. So so this is actually searching Redis. Yeah, so that it really depends on your indexes and that sort of thing, and how many records you have in your database, and all of those fun databasey things that we all love to do. But generally, it's pretty quick for us. The vector search issue I was getting was a timeout issue, which I'm pretty sure there was something wrong with my index. But yeah, I didn't get to fix that. But yeah, you saw in memory searching with, again, I have 64 gig of RAM on my desktop at home, which it's running on, which is not a huge amount of RAM, but it's also not a little amount of RAM, it's able to crunch through it pretty quickly. Sorry.
Was in your initial demo, the first question took quite a while, but the second was very quick?
Yep, so that's because Ollama has to load up the model on that first request, so it brings bringing DeepSeek, and that model file is 5.5 gig. So it's bringing all of that into VRAM on my GPU. So you can run it on your CPU. It's much slower, but it is doable. But I'm running NVIDIA 3080 at home, so it's quite snappy. And it has 12 gigabytes of VRAM, so it's able to hold the entire DeepSeek model in memory at that time. So once it does that, it's able to then query that very quickly. If you then were to load up, say, Qwen, if you wanted to try out that different model, it has to load Qwen into memory, and it also unloads DeepSeek at the same time.
Oh, that's cool.
So you can get timeouts when
And
that
did,
happens.
I see. And did you guys like see how many questions you could ask before it just runs out, or like just stops responding?
No, what we would generally, because that's, I guess, based on the context window, and over time, the code we actually wrote dropped off the old questions as being less relevant over time, so we didn't need to include them if we hit the context window on the model. Okay.
You mentioned that the embedding uses Euclidean distance, right?
I was using cosine similarity, but yes, you can use Euclidean distance.
That's to create the clusters that the vector search can then use later on? Or is that
Yeah, so that's using Euclidean distance between the search embedding and the database of embeddings and pulling out the most relevant ones. Yeah.
Is there any more ways to how to test or verify about the generated rack system?
Any more?
Because I want to build a rack system, I don't want to verify whether the prompts or the queries from the LLM is more specific to the scenario.
Honestly, mostly just manual testing. Unfortunately, yeah. It's the only way. Yeah, just trial and error. You could potentially look at using multiple models to compare the results of what you're getting. The thing with the embedding models is you have to use the same model for your embeddings for your query as you did to generate your database. If you use two different embeddings models, you have to regenerate your database every time you switch. So, because they all have plot things with in different spaces in vector space.
I'm someone who's never used .NET before, I'm not familiar with C#. And the title of this talk was more Python, right? Yeah, just learning with it. So I was just curious to know what does this have to do with Python, like in terms of replacing the technology? Because from what I've seen, I feel like Node.js could do a lot of.
Oh, absolutely. It's like this is more about introducing the patterns in a .NET space, because more of a .NET talk. But yeah, and my title was more tongue-in-cheek than anything. I really liked The Simpsons growing up, so I wanted to make a reference. Anyone?
So the model you're using for this, how does it do with like extended reasoning? Say, for instance, your leave accrual query, if the user would instead say, I work 2 days a week, what my leave occurrence, would it go that extra step back? Or is that even desirable in your use case?
Not in the way it's implemented at the moment. So currently, once it's moved past that query, it won't look up documents. So because once it looks up those documents and then responds, but then the second time you go around, it's going to look up documents based on your most recent query. So the previous information is gone. So your second query has to, if you want to do that follow-up, you have to include all of the original query again as part, as in the user would have to type it all out and then ask for the additional information so it could look up those same documents. So not well.
You'd have to essentially, if you wanted to implement that with your current model, you'd essentially have to requery the Redis for every previous thing to add all of the...
Yeah, and then you're going to hit your context window of tokens very quickly.